Good evening. My name is Devlina Maiti. I am an NPTEL TA for the course Basic Real Analysis, and this is the 10th tutorial class. So in this session we are going to discuss problems from double and triple integration. Okay, I will wait for 1 to 2 minutes and then I will start. Am I audible to you?
Yeah, it's audible.
Okay. Okay, I'll start. One second. Okay, so the first problem is dA means dx dy. Okay, and D is the region. So here D is the region bounded by x-axis, x equals to 2a ordinate, and the curve x square equals to 4ay, the parabola. And second is this bounded by these two curves. And the third one is y equals to x minus x square, y equals to 0, x equals to 0, and x equals to 2. Okay, so we'll solve first A. So here D is the region bounded by this 3 curve, right? So what is D first? We'll check. So x square equals to 4ay, it is the parabola. this, and what, x equals to 2a. So this is x square equals to 4ay, and this is going to be x equals to 4a, sorry, x equals to 2a, the line. Right? And x-axis, this is the x-axis, right? So the region bounded by x-axis, the line x equals to 2a, and the parabola is this region, is this portion, right? And what is the point here? Here the point is 2a 0. Can you please unmute, or is there any question?
No. I thought I cleared it myself.
Okay. Okay, so the point, this point is 2a, and what is this point? So if x is 2a, y is going to also be 2a, right? From this equation, this is the intersection of these two curves, right? So what is the limits of x and y here? So xy dx dy, right? So x runs from 0 to 2a, and y runs from, if we go like in this way, y runs from 0 to x square by 4a, right? So if we go in this direction, you will see that. So if we, so y here is this line, y equals to 0, and in this point y is x square by 4a, right? So y runs from 0 to x square by 4a, right? So now we'll integrate. So it is going to be 0 to 2a, and x into square by 2. Now this is just calculation. You will see that this is going to be x to the power 5 by a square dx, and this value is which is a to the power 4 by 3. Okay. So first we have to draw and find out the limit of x and y, right? So let's do B. So for B, our D is the region bounded by y equals to root x and y equals to x cube, right? So first, y equals to root x, how does it look like?
Yeah, inverted parabol.
Yeah, like this one. So this is y equals to root x, and y equals to x cube will be this, and they will meet at the point 1, right?
0.
1 1. At the point 1 1 they will meet. When x equals to 1, y equals to 1.
Okay.
1
And
1
now
point.
it's 0.
Yeah, 0 0 is there, 0 0 is there, and 1 1 also with the also in both the curves, right? So we have to find out the region between these two, the area between this, no, not area, we have to integrate in this region, right? So the region is this. So limit, we'll find the limit of x and y from this region. So this is, so this point is 0 1, and this is 1 0. Right? So the integration, so what we have? We have integration of d 4xy minus y cube dx dy. Right? Now we have to find out the limit. Now x, here x runs from 0 to 1 and y, so if we look at this direction, so y in this region, y first meet here, this point, at this point, right? So at this point y is what? This curve is y equals to x cube, right? So at this point y is x cube, and in this region, when this region ends here, y is root x, right? So the limit of y will be x cube to root x, right? And limit of x will be 0 to 1, right? So this is the region. So now if we integrate, we'll get 0 to 1. This is 4x it will be 2x, sorry, if we do the calculation, it will be 7 by 4 x square okay, and this value is going to be, it is just calculation, you can do it on your own. Okay, so this question is done. And for the C, the region was y equals to x minus, okay, I'll write it. So the region is y equals to, bounded by y equals to x minus x square. Now we have to look at the curve x minus x square. Now it is not an increasing or decreasing function. Okay, so we have to see it. So if we name it as fx, so if we do f dash x, it will be 2x, right? You see, from 0 to 1, it gives positive value, and after 1 it gives negative value, right? This is 1, and it will be increasing and decreasing in 0 to 1. So it will be greater than 0 if x less than 1 by 2, and f dash x less than 0 if x greater than half and less than 1. No, when x greater than 1, greater than half, right? So till half it is increasing, so sorry, yes, it is increasing and then decrease, and it is 0 at 1, x equals to 1, right? So it will meet at x equals to 1 and then decrease. So here is our 2. So we have to find this y equals to x minus x square, y equals to 0, x equals to 0, and x equals to 2. So up to x equals to 2 we will, so this is another line, x equals to 2, right? This is y equals to x minus x square curve, and this is x equals to 0, right? So the region is what? So the region is this portion. So D is this region. Okay.
So what about y is equal to 0?
I think it is not, it will not be here. So y equals to 0 means this line, this, yeah, y equals to 0 mean x axis, right? Oh sorry, this is y equals to 0. Y equals to 0 is x axis. X equals to 0 is not needed. X equals to 0 means y axis, right? Y axis, there is nothing bounded by this y axis.
Okay.
Okay, so we have to find this region. So we will do this in two parts. So I1 is the first one from 0 to 1. So it is, suppose this is D1 and this is D2, right? So this is D1 plus double integration of D2, this is D. So first we'll find this D1. Suppose this is I1 plus I2, right? Now I1 is the first one. So x goes from 0 to 1 here. And y runs from 0 to, it is what curve? The curve is y equals to x minus x square. So y here runs from 0 to x minus x square. And the value was what? X square. Right. Okay. Just quickly calculate it. So it will be x square y plus right, and this is going to be now if you do the calculation, you will find out that this value is 27 by 70. Okay, and this is going to be 0.385, something like that. And for I2 the limit is what? So for I2, x goes from 1 to 2. So x runs from 1 to 2, and here y runs from the curve to 0. So y runs from x minus x square to 0, right? Okay, just do the calculation and you will find out that this value is 210. Please do it on your own. Okay, check. So I will be, this is going to be 6 point. Okay, so we have solved this question 1. Okay, let's go to question number 2. So question number 2 is we have to find out the integration by changing the variables. Okay, so evaluate the following. No, actually it is changing the order. Means if you have dx dy, then first you have to do dx dy. Dx dy, then we have to do dy dx. The order of the integration. Then we will go to the changing of variables. Okay. So the first one is 0 to 4a. dy dx. This is 2 minus x square so we have dy dx, and then we have to solve it by first changing dx dy. Okay, so first we have to find out the region, and then we have to find out the limit, how the limit changes. Okay, not, we cannot do this goes to this and dx dy, right? Because y depends upon x. That's why we cannot change here. We cannot write 0 to 4 x square by 4a to 2 root x and then 0 to 4a dx dy. Okay, so for a, so what is this region? So x here runs from 0 to 4a, right? Let's say this is 4a, and y runs from x equal, so y to root over x. Now what is this curves? This is y, and y equals to 2 root over x. So it is x square equals to 4ay, and it is y square equals to 4x, right? So y runs from this curve to this curve, right? So x square equals to 4ay, it is this parabola, right? Like this, and this is y square equals to 4x, and x square equals to 4ay is this one, right? So this is x square equals to 4ay, and this curve is y square equals to 4x. So y runs from this first, what we have, y runs from x square equals to 4ay, this curve. X means the lower one, right? So what we are given is that in this direction we are given, right? So we have x runs from 0 to 4a, and y runs from this curve, this x square equals to 4ay, this point to this point, right? In this direction we are the problem is given. So first we have to change it. So first we have to change it to horizontal direction, right? So to horizontal direction means this line we have to change, right? So we have to find out where x varies. So here x changes from this point to this point, right? This violet line. So in this line, the first one lies in the curve y square equals to 4ay. So x runs from this curve, this y square equals to 4ax curve to x square equals to 4ay curve, right? So x runs from y square by 4a to 2 root over ay, right? So this is how x is in this region, how x is changing, right? The region is this one. So we are given in the vertical direction how y changes. Now we are doing what? How x changes. So what we have? Oh. So we had 0 to 4a, and y ranges from x square to x square by 4a to 2 root x dy dx, right? Now we know that x changes from y square by 4a to 2 root over ay, and y changes from this point, y changes from 0 to this point. This point is what? This here
4.
4a, right? So this point is actually 4a 4a, right? So y changes from 0 to 4a, and the limit changes. This is dx dy, right?
You said due to the symmetric about y is equal to x line.
No, this point is the intersection point of these two.
No, I'm asking a question that if y is equal to, if we draw a line y is equal to x,
Yes.
so if we rotate about y is equal to x, if the area remains same, we can do this change
Yes.
without.
If this is symmetric, then these are changing in this way.
Okay.
But here it is a different curve. Okay, so what is this value? So this value is 2 root over ay minus and this will be 16a square by 3. Okay. So check the calculation. Okay. And for the second one, what we have? We have 0 to 1, x runs from 0 to 1 and y runs from x to root over 2 minus x square, right? X by dy dx, so sorry. So first dy then dx. Okay. Now what is this region? So y runs from y equals to x. So y equals to x line is this one, and y equals to root over 2 minus x square. So what is this curve? This is actually the circle, right? So it is going to be circle. Okay, this is not a circle. Okay, something like that. Okay. So this is the circle, and since what we have x runs from 0 to 1 and y goes from this curve first from y equals to x, then to y equals to, this is y equals to root over 2 minus x square, right? So from this curve to this means in this direction. So the region is what? So the region is this portion, right? X runs from 0 to 1 and y runs from this curve y equals to x to this curve root over 2 minus x square. So it is going to be this region. Now we have to do the calculation in changing the order. So it means we have to change from in this direction, right? In the horizontal direction. Now see, there are two different ways. In this point, the upper in the point, this is intersecting from this x equals to 0 to this curve y equals to root over 2 minus x square. Above this point, this intersecting point, and lower of this curve, first y is x is where x is 0, at this point x is 0, and at this point x is y, right? So there are two different points are they are going, right? So we have to do the calculation in two different,
two separate intervals.
yes. So this means, so d, this is d, so we'll write it as, so I1 so we are going to write it as so first one is, so x runs from 0 for the, okay, I'm going to name it, this is O, A, B, and this point is C, right? So if this is I, then the value of I will be, I1 means this OAC plus I2, this is ABC, right? So the first I1 is what? OAC means x varies from 0 to x, 0 to y, right? For the lower 0AC, x runs from 0, this is this 0, and this point is y equals to x curve, and y runs from, so y runs from 0 to this point. So this point is what? This point is 0, 1. C is 0, 1. Right? Because at 1, A is 1, 1. So this is 0 to 1, xy root over x square plus y square. Now dx dy. And the second one is, so here x runs from 0 to this curve. This curve is root over 2 minus y square, right? And y goes from 1 to 2, this point.
Root 2, right?
0 to?
1 to root 2.
Oh yes, this is root 2, not 0 to. The circle is of radius root 2, right? So x square plus y square was 2. Okay, just do the calculation. I'm not, okay, first, first one will be and this value is √2 minus 1 plus and this will be √2 minus 2 . Okay, so we have done it in two parts, right? So first we have to find the region, then we have to find the limits of x and y. Okay, go to the next question. This is e to the power y by x plus y dy dx. Using the transformation x plus y equals to u and y equals to ub. So we are changing from xy to ub. So we are changing variables. Right. So first we have to find, in changing variables, we have to find the limits and the Jacobian of the transformation, right? So what we have? We have x plus y equals to u and y equals to uv. So x is u minus y, which is, and y equals to ub, right? So what is this Jacobian? So the Jacobian is what? This is del xy, del uv is what? This is del x del u, del x del v, del y del u, and del y del v, right? So here this is 1 minus v, this is minus u, and this is vu. So it is, so the Jacobian is u, right? So we know this dx dy equals to del x del y del uv du dv, right? So we'll change from xy to uv variable, right? Now we have to find the limits. So xy are changes from 0 to 1. So we have to find how uv are changing. So first we have to find the region of xy. So x changes from 0 to 1, 0 to 1, and y is changing from 0 to y minus 1. So when y is 1 minus x, this means x plus y equals to 1, right? So x plus 1 equal, so this one, this line is this is x plus y equals to 1 line, right? X by 1, y by 1. So this point is 1 0 and this point is 0 1, right? And y runs from 0 to this point. So if we see in this direction, this is this region, right? Here y is 0 and at this point y is 1 minus x. So this region we are considering. Now when we change to uv, so now our coordinates are uv, right? So what we have, what is u? U is x plus y. U is x plus y, and x plus y is changing from x plus y is changing from 0 to 1, right? So u is changing from 0 to 1, right? So these lines are, all these lines are x plus y equals to some constant, some c. So when at this point, at this is x plus y equals to 0, so it is going to be 0 to this point. So this is 0 and here it is 1. So u runs from 0 to 1. From 0 to 1. Now where v is running from? So we have y equals to ub, right? And our y was what? Y, the value of y was from 0 to 1. So this value is from 0 to 1. So 0 less equals to ub less equals to 1. Okay. And this is true for, if we look at v, so this is true for any u and v, right? So if we take u to be 1, because u runs from 0 to 1, so if we take the value u to be 1, then the range is 0 to 1, right? So v also runs from 0 to 1. So it is actually the square region, right? So u runs from 0 to 1 and v runs from 0 to 1. So this is v equals to 0, v equals to 1. This is u equals to 0 and u equals to 1, right? This. So if when we changing the coordinates, this region becomes this one. This triangle becomes the square, right? Now we'll integrate. So our integral was 0 to 1, 0 to 1 minus x e to the power y by x plus y, by x plus y dx dy, right? Sorry, dy dx, right? So in uv term, so our u and v both are running from 0 to 1, and it is y is uv and x plus y equals to u, and dx dy equals to this Jacobian was u into du dv, right?
So I have a doubt. In the integral we have dy dx, but the Jacobian formula is saying dx dy.
This is same. If we just dy dx, then we will integrate. Then the formula becomes dy du and dx dy. This is actually mod of this thing. Modulus we are taking. in the formula.
I'm asking the dx into dy is equal to the formula, and the in integral it's dy into dx. Can we interchange it? I mean,
Yes,
can we
then the matrix here, this at this point, if we just take del yx del ub, then the upper will be del y del u del y del v del x del u and del u del v. And since this is a matrix, so it will be minus of that, right?
Okay. Yes.
And since we are taking the determinant to be modulus value, then it will be the same value in the integration. Okay. This comes from the change of matrix. Okay, here, so it becomes e to the power v u du dv. Now this is for v, right? So it is e minus 1 by 2. Okay? Okay. Okay. So this problem is done. So question 4 is again from transformation. So consider this transformation t from the xy plane to the uv plane. Given by, the transformation is given by x equals to u plus v by 2 and y equals to u minus v by 2. So first calculate the Jacobian. Calculate the Jacobian of the transformation of t. Jacobian of t, and then find the evaluate using the transformation t, where this t is the square in xy plane with vertices 0 0 pi pi 0 2 pi and minus pi pi. Okay, so you are given this transformation t, which is u plus v by x equals to this and y equals to this, and you have to first calculate the Jacobian of t and evaluate this integration over this region. Okay, so in xy plane, what is this region? So this is a square with vertices 0 0. This is some pi pi. This is minus pi to pi, minus pi pi, and 0 2 pi, right? So this is a square with vertices, these 4 points, right? So D is this region, this is our D. Now first we have to find the Jacobian. So x is u plus v by 2 and y is u minus v by 2. So the Jacobian uv is what? So first is half, and this is also half. This half, this is minus half, right? So it is going to be minus half. Okay. Okay, so the integration, so first we have to change the coordinates variables, and then we have to find the integration, right? So for 2 we are given the d, so this is d. So first we have to find the limits of u and v, right? So u is x plus y is u, right? X plus y is u, and v is x minus y, right? X minus y is v, so this is xy plane. Now if you look at the y uv plane, so you have to find the limits. So first look at this line. So in this line, the equation of this line is what? This is x minus y is 0, right? This line. And what about this line? This line is x minus y equals to
2 pi.
Minus 2 pi.
Okay.
Minus 2 pi, right? And what about these two lines? Oh. Sorry for this disturbance. This is visible now, right?
Yeah.
So for this line, this line is, the equation of this line is x plus y equals to 2 pi, right? And this line, x plus y equals to 0, right? So if we look at in this section, so x plus y runs from 0 to 2 pi, right? So we have to consider this region, this D. So in this D, this x plus y goes from 0 to 2 pi. And similarly for x minus y goes from 0 to minus 2 pi, or we can say from minus 2 pi to 0, right? So the limit of u and v, what we get? So u runs from, u is x plus y, and x plus y runs from this 0 to 2 pi, and v runs from v is x minus y, right? So x minus y is here minus 2 pi to 0, which is small. I am writing this in the first. So minus 2 pi to 0, right? This is the limit of u and v. So now what is the integral? So integral becomes u from 0 to 2 pi and v from minus 2 pi to 0. And x minus y is our now v. This is cos square x plus y is u. And this modulus value of this is half mod value, and then it is du dv, right? So this is, if this is I is same, changing the variables. Now if we integrate, so since these two are independent, u and v is not depending, right?
We can change it to?
Yes, so u here 0 to 2 pi, so u is cos square u du, and v is minus 2 pi to 0, this is v dv, and there is half, right? Now this is v square by 2, this is u by 2. With this 1 plus cos 2u, then it will be sin 2 pi 2u by 4. It's 2 pi 0 into, right? And this is minus 2 pi square, and this will be pi. So it will be minus pi cube. Okay. So this is the final answer. Okay. Again here this is a square. So in uv, what does this look like? So u runs from 0 to 2 pi. U is 0 to 2 pi and v is minus 2 pi to 0. So it is this region, this square. This is in UV plane and this is XY plane. Okay, this is 2 pi minus 2 pi. Okay, so we'll go to the next question. So question number 5. Evaluate the integrals by making an appropriate change of variable. So first one is this d x square dx dy, where d is the elliptic region this xy, this, and the second problem is d y square dx dy, where d is the region bounded by the curve xy equals to 1, xy equals to 2, xy square equals to 1 and xy square equals to 2. Okay. So we have to find the integrals by changing the variables, right? We are not given the change of variables, like here we are already given the transformation, right, in question 3 and 4. So now we have to take the variables for simplification of this integration, right? So for the first one, what will we choose? So we are in this xy plane, this is an elliptic region, right? So for changing of variables, what do we choose for simplicity? Any guess?
No.
For circle, what do we choose? If we are given a circle x square plus y square equals to 1, so what is this? Its polar form?
R cos theta, R sin theta.
Yes, for x equals to r cos theta, y equals to r sin theta, right?
Yeah.
Here this is the same thing. See, for x, if we choose x to be 2r cos theta and y to be
3R.
3r sin theta, then x square plus y square will be this
One.
form will be 1, right?
Okay. Yes.
So we choose x to be 2r cos theta and y to be 3r sin theta, right? And where since this is the whole elliptic region, so r varies from, so limit of r is 0 to 1, right? And theta
0 to 2 pi.
0 to 2 pi, since this is the whole elliptic region, right? So now what is the Jacobian? Since we have changed the variable, we have to find the Jacobian. So if we quickly do this, this will be 2 cos theta minus 2r sin theta. This is 3 sin theta and 3r cos theta, right? And this is 6r. No, sorry, this is 12r. Oh, sorry, 6r. Cos square plus sin square, this will be 6r. Okay. So now what is this integral was d of x square dx dy, right? So in r cos theta, r and theta, so r varies from 0 to 1, theta varies from 0 to 2 pi, right? So x is 2r cos theta, so it is 4r square cos square theta, and dx dy is 6r dr d theta. For circle it will become r dr d theta, right? Because the Jacobian will become r, right? So now if we just quickly solve it, it will become 0 to 1, 0 to 2 pi. Okay, it becomes 0 to cos square theta d theta, which will be 6 pi. Just check the calculation, okay? Okay, the first one is done, and for the second one is easy one, right? So the curves are xy equals to 1 to 2 and xy square equals to 1 to 2. So what will you choose for change of variables for simplicity?
xy is equal to u or v.
Yes, u equals to xy and v equals to xy square, right? This is the simplest. So then u runs from 1 to 2 and v runs from 1 to 2, right? So I found the limits easily. So here we see that changing the variables, the integration becomes easier, right? That's why
Yeah.
we change variables. Not always we do that. If the question says you have to change the variables, then you have to do that. But for simplicity, you can do this from polar xy plane to r theta plane, right? So here this integration becomes dy square dx dy 1 to 2, v is 1 to 2, and y is what? Y was here, y will be v by u, right? Oh, I have not found the Jacobian, right?
Okay.
So
Do you want me to find the Jacobian?
yes, just tell me
Sure.
the value.
One over h square by y. 1 over h into, I mean 1 over v.
Yes, 1 over v in uv form, right? So the integration, this is 1 to 2 just find out the value of this integration. So it is now v by u square, v by u square du dv. So for v it will be 3 by 2. So it is 3 by 4, right?
Okay.
So we have done solved this one. So let's go to the next problem. So this is triple integral. So find the volume bounded by the cylinder x square plus y square equals to 4, and the planes y plus z equals to 4 and z equals to 0. Okay, so we have a cylinder and two planes, and we have to find out the volume between these planes. this is a cylinder, right? Because z is not here, so z is arbitrary, z can take any value. So first make a cylinder. So this is a cylinder, right? This is z, this is suppose y, x, and this curve, this in xy it is a circle, right? In xy it is x square plus y square equals to 4, and the plane y plus z equals to 4. So what is this point? This, it is intersecting y axis at the point what? 0. This x square plus y square equals to 4, right? So it is 0 2 0, right? And this point is 2 0 0. Okay, and we have to find y plus z equals to 4. So this means y plus z equals to 4 means it will cut y axis at the point 4, right? So this point, this is 0 4 0. So the curve look like, and here is some 4. So if we, this is 4, so this is going to be 4. So this line is y plus z equals to 4, right? So this line is y plus z equals to 4. So since in 3D it will be a plane, right? Y plus z equals to 4, but x is arbitrary, so this is a plane. So this plane cuts the cylinder, right? So the intersection will be of this form, the intersecting segment, right? Since it is a plane, it is cutting the cylinder. So this portion, this is the plane y plus z equals to 4, right? So now we have to find out the limits. So xy is in this circle, so xy and z from z equals to 0 is this plane, xy plane. This is z equals to 0 plane, right? So z runs from 0 to this plane, this blue segment, right? So z runs from x equals to 0, z equals to 0 means xy plane to this section, right? So the integration, so the volume will be what? And for volume, what is volume? So volume B is integration of dz dx dy, right? This is the volume of the volume formula. Now for limit, so x and y belongs to this circle, x square plus y equals to 4. So x and y runs from -2. So if we say y runs from -2 to 2, x runs from, so y runs from -2 to 2. It is a circle, so x runs from minus root over 4 minus y square to plus root over 4 minus y square, and z runs from this plane z equals to 0 to this plane, right? This portion, this z equals to 0 to this section. So the equation of this section was y plus z equals to 4. So it is 4 minus y, right? And this is dz dx dy. Okay, so this value is this is 4 minus y dx dy, right? Since there is no x, so it will be 0 to 2 into 0 to and since there is no x, so it is 4 minus y into root over 4 minus y square, right? Now if we do the calculation, then it will be 4 into okay. Now this section, this y into root over 4 minus y square is a odd function, right? So the integration from -2 to 2 will be 0.
Yes.
So only the first one will left. So this is 4 minus y square dy, and the value of this is even. It is 16 into, the integration is sine square y by 2, right? So the value is 16 into 2 sine inverse 1, which is it will be 16 pi. Okay, so the volume of this region, this portion, right? So we are finding the volume of this portion bounded by z equals to 0 and this plane of this cylinder. So volume of this we have found out, this is 16 pi. Okay. Okay, so let's go to the next problem. Zero to 6. Yes. Using the cylindrical coordinate. We have to find this integral using the cylindrical coordinate. Now what is the cylindrical coordinate? It is the same thing. Cylinder is what? This is a circle and z is unbounded, right? So it is the equation, polar form of this circle. So here also x is r cos theta for cylinder, y equals to r sin theta, and z is arbitrary, z is unbounded, can take z to be anything, right? The base is the circle, right? So this is the cylindrical coordinate. Right? So now what is this region? This region we are given 0 x runs from 0 to 5, y from this, and see here this is a form of cylinder, right? Because y runs from 0 to root over 25 minus x square. So y equals to root over this means x square plus y square equals to 25, right? So this cylinder, and z is from 0 to 6, but z does not depend upon x or y, right? Z is independent, so it is a cylinder. So the cylinder, but it is in the first octant because x is positive, y is positive, right? So this is
Yes.
the portion of the cylinder in the first octant. So this looks like,
Is the answer is 15 pi?
what?
15 pi, and is the answer is 15 pi?
Answer, yes.
Okay.
So so the portion of the cylinder in the first octant is this. Right? So this is x square plus y square equals to 25. Since x and y are positive, we are taking the first octant. And this plane is z equals to 6, and this plane is z equals to 0. Right? So this region. So the value is, so since okay, so we have to find the limit of r and theta. So z runs from 0 to 6, r runs from this is 5, 0, so r runs from 0 to 5, and theta runs from, this is theta, so this is, the whole theta is pi by 2, so theta runs from 0 to pi by 2. So the integration becomes, now if we find out the Jacobian is here, this is 3 coordinate, x, y, z, and this is r, theta and z. So it is the same thing, x, y and r, theta. So it is going to be r for circle. Okay, so the integration becomes then, this r runs from 0 to 5, theta runs from 0 to pi by 2, and z runs from 0 to 6, and this is r dr d theta dz by, this is r, so dr d theta dz is only the thing, so these two cancel out, means 5 into pi by 2 into 6, so this is 15 pi. Okay, sorry. Okay, so let's go to the next problem. Now we'll use the spherical coordinate. So for question 8, so we have to evaluate this 0 to 1, 0 to 1 minus x square, 0 to 1 minus x square minus y square. Using the spherical coordinate. Okay, so what is the spherical coordinate? So you have to put x equals to r cos r sin theta cos phi, y equals to r cos theta, sorry, this is again sin theta, sin phi, and z is r cos theta. Okay, so this is the polar coordinate of sphere. So this is a spherical coordinate. So now if you see that x, y, z are positive, so again here we are seeing the sphere in the first octant, right? So here in the first octant, so it will look like, since it is a sphere, so in xy plane it is, in each plane it is a circle. So it looks like this, right? Since x is positive, x is runs from 0 to 1, so this is 1 0 0 and this is 0 1 0, right? And this equation is x square plus y square equals to 1, because y runs from 0 to 0 to root over 1 minus x square. So this satisfies this equation, x square plus y square equals to 1, right? And z is this curve, this, right? So theta is what? Now theta is, so what is theta? So if we take this point, if this is an arbitrary point, if we project in the x-axis, this angle is phi and this angle is theta. Okay, this is r, and r is this portion, this is r. So this is the coordinate r, so in xyz, and we are going to r theta phi, this plane, right? So we have to find out the limit of r, theta and phi. So r runs from, so here r runs from 0 to 1, right? So this is 1, the circle, radius of this circle is 1, and theta runs from, since this is in the first octant, so theta can be maximum pi by 2, right? This is theta, 0 to pi by 2. From here it can go to the xy plane, so it is going to be pi by 2 then. And phi runs from, so phi is this one, so phi is this angle, so this angle can be maximum pi by 2, so also 0 to pi by 2, because this is in the first octant. So now the integration becomes, in r theta phi, r runs from 0 to 1, theta from 0 to pi by 2, and phi also from 0 to pi by 2, right? And yes, we have to find the Jacobian first. Okay, so the Jacobian J is now xyz. This you have to find out, right? This is a 3x3 matrix now. Right, this you have to check. So this value is going to be r square sin theta. Check it, okay? This simple calculation. So now if this is j, so our integration becomes So it was xy dx dy, so 1 by 1 plus x square plus y square plus z square, right? And x square, from this 3 you will see that x square plus y square plus z square equals to 1. Oh sorry, is equal to r square, right? So this is 1 by 1 plus r square, and j is r square sine theta, and it is dr d theta d phi, right? So if it is I, then I becomes this one. Okay. Now just do the calculation. So it is so there is no phi, so pi by 2 will be cancel out, only sine theta, and 0 to 1, this is r square by 1 plus r square dr, right? So this value will be and this is r minus tan inverse r. So you can write it as 1 minus 1 by 1 plus r square, right? This one you can write it as 1 minus r square, and then it is r minus tan inverse r, 1 0. Okay. It's pi by 2. This is 1 minus tan inverse 1 is pi by 4. This is minus cos theta. So it is pi by 2 into 1 minus pi by 4. Okay. So we have find out this integral using spherical coordinate. Okay. Okay, so let's go to the last question of this session. Now it is visible, right?
Yes.
I don't know what is happening. Okay, so I will not touch here. So the problem is the region no, notice the region. We have to find the integration of evaluate this square plus y over the region in the first octant between the paraboloid this x square plus y square equals to 2z and the cylinder x square plus y square equals to 2. Okay. So D is this region, right? So over D we have to find out this this integral, right? So it is in the first octant and it is between the paraboloid and the cylinder, right? Now cylinder looks like this, right? This is the cylinder. Suppose this is the cylinder, x square plus y square equals to 2. Okay. And parabola looks like what? It is like an umbrella over this parabola, right? This is a parabola. Now if we imagine this in a single picture, so the portion will look like, so this portion so it will become this region, right? This. So I have to find out the region between these two, this paraboloid and this cylinder. This is under this paraboloid and over this cylinder, this portion actually. So this, right? So if I draw it again. Okay, and it is in the first octant. So we have to find the region in the first octant, not the whole. So in the first octant, the cylinder is like this, right? Right? In the first octant, and the paraboloid is this. Okay. So under this portion. Is it clear?
Yes.
Okay. So this portion we are going to consider in the first octant between this paraboloid and this inside this cylinder. Okay. So and for cylindrical coordinate we have x equals to r cos theta, y equals to r sin theta, and z is arbitrary. So here this region D is what? Region D is where z runs from. Z is what? Z runs from this xy plane, that is this is xy and this is z. This line is z, right? So this plane is xy plane, so here z is 0. So this equation is x square plus y square equals to 2 and z equals to 0. So z runs from this this plane to this paraboloid. So the equation of this paraboloid was x square plus y square equals to 2z. So z goes to x square plus y square by 2, and then y runs from y and x in the circle, so y runs from 0 to root over 4 minus x square, since this is a circle, and x runs from 0 to 2.
Root 2.
It was x square plus y square equals to 4, right? Yes.
X square. Then in the y is less than or equal to 2 minus x square.
Okay, I think I have written the question. This is x square plus y square equals to 2z and x square plus y square equals to 2. Z equals to, yeah, it is 2 minus x square. Okay, I'll check the question 1 second. I think it will be x square plus y square equals to 4. Then it will be right? The question, yes, x square plus y square was 4. It's a small mistake. So then it will be 4 minus x square, and it is only 2.
But then z is equal to 2. Okay, fine.
Z is x square plus y square by 2, the paraboloid. So z goes from this plane to the paraboloid, and xy is in the circle. So now if we integrate, so since this is a cylinder, the Jacobian will be r, right? So if we integrate now, so r goes from 0 to, x r goes from 0 to 2. Theta goes from 0 to pi by 2. Since this is in the first octant, right? This is theta. Whole is pi by 2. And what we have? We have z. Z is 0 to x square plus y square by 2. Oh, sorry. Now it is in the r. So z. So x square plus y square equals to r square. So r square by 2. Right? I'll write in the next line. I will write in the r cos theta. So this is dx, dy, dz. Zero to r square by 2. And z is as it is, because z is here a variable. So z and x square plus y square is r square, so it is r, and the Jacobian is r, and it is dr d theta dz, right? Because Jacobian of del x y z del r theta z is going to be r. Okay, so r will be cancelled out. 0 to 2, theta is 0 to 2 pi by 2, and z is here, so z dz will be r z square by 2. To pi by 2, and it will be r to the power 4 by 8 dr d theta, which is going to be is going to be 4 by 5 into 2 pi by 2 d theta, which is 4 by 5 into pi by 2. So the value is 2 pi by 5. Okay, it is fine, right?
Yeah, fine. So can you share this note?
Yes, I will upload it in the sheet. Okay, Google sheet, this and the recorded video also.
Where it will be uploaded?
I think they have shared the Google sheet, right?
No, I didn't attend any class previously.
Okay, if we check the mails, then there is a Google sheet. I think they have shared the link. There all the videos we have recorded and the notes are there. Okay.
Okay. Okay, thank you.
Okay, if there is any doubt in this session, you can ask.
I had not in this session. I had in sequence and series, so I couldn't answer.
Okay, it's fine. Okay, so we'll end this session now.
Okay.
Okay. Okay, thank you.
Thank you.